Let us now proceed to the next topic of this video, and that is operators. The first point says that operator is a symbol, and what it does is that it tells the compiler to perform some specific operation, and this operation is performed on something known as operands, and a value is returned. Now before we move forward and talk about different operators in C, let us talk about expressions, operators and operands. Now these two are something known as an expression, and these two expressions are made up of operators and operands. Now if you look closely at these two expressions, these are two valid expressions in the world of maths, but be a valid in the world of programming. What it says is that the variable which is to be assigned a value should always be on your left hand side of the expression, and the expression which results into a value which then gets stored into this variable should be present on the right hand side of the expression. Now if you look closely at this particular expression, you'll see that we have two variables x and y, which are also known as our operands, and the plus symbol which acts on these two operands is something known as an operator. Having said that, let us now discuss the first operator, and that is the arithmetic operator in our program. This is a very simple program which shows the use of our arithmetic operator, and the arithmetic operator are addition, subtraction, multiplication, division and modulus. Now what I have done in this program is that I have declared two variables, integer variables v1 and v2, and I have assigned 10 and 20 to them respectively, and then I have made use of a printf function and print 5 integer values. Now if you are wondering why it is an integer value, it's because I've made use of %d as a format specifier. Now if you pay close attention to this particular line, you can see that within the double quotation mark I've given 5 format specifier which are separated by commas. Now what does this mean is that on your output screen you will be seeing 5 integer values which are separated by your commas, and these values are nothing but a result of these expressions. So the first expression v1 plus v2 goes to the first %d, the second expression v1 minus v2 goes to the second %d. Similarly for the third, fourth and the fifth one. Now if I go and execute this code, you'll see an output which looks somewhat like this. In this output you can see 5 integer values which are separated by commas. So 10 plus 20 is 30, 10 minus 20 is minus 10, and then 10 into 20 is 200, then 10 divided by 20 is 0, and 10 modulus of 20 is 10. Since this modulus operator gives you a remainder. Now what I want you to do is that try out this same program but with different data types. I've used integer data type, so you can make use of a float data type, a double data type. You can even make use of mixed data type like integer and double or integer and float. You can even try out with non-numeric data type like the char, but for char only addition and multiplication will work. Others will result into an error. Let us now discuss about the second operator, and that is the assignment operator. This is a very simple program that shows the use of assignment operator. The assignment operator is used to assign values to a variable, just like this line of instruction shows. The example of assignment operators are equal to, plus equal to, minus equal to, multiply equal to, and so on. Now if you look at the first line of code inside the main function, here I have declared a variable v1 which is of integer data type. Then in the next line what I have done is that I have assigned a value of 10 to variable v1, and out here I have made use of assignment operator equal to. Then in the next line I have declared another variable by the name v2 which is of integer data type, and I have even assigned a value of 20 to this variable. Now what I want to do is that I want to add the value of v2 and v1 and store the result into variable v2. And in order to carry out this particular task, I have made use of a shorthand expression. Let us now discuss the third operator, and that is the relational operator. Well, this operator is used to provide a relationship between two expressions, and the return type of this operator are always in terms of boolean, that is in terms of ones and zeros, where 1 is considered to be true and 0 is considered to be false. This is a very simple program which shows the working of our relational operator. Now the example of relational operator are greater than, less than, equal to, greater than equal to, less than equal to, and not equal to. Now if you look at the code within the main function, you will see that I have declared two integer variables v1 and v2 and assigned them a value of 10 and 20 respectively. And then what I have done is that I have made use of a printf function, and I have provided an integer format. Now the reason why I have provided integer format specifier is because I know that a relational operator always provide me with I know that a relational operator always returns a value of 0 and 1, where 0 is considered to be false and 1 is considered to be true. Now what I have done in this expression is that I'm saying that 10, which is the value of v1, is equal to 20, which is the value of v2, and that is surely not correct. So that's the reason why I'm getting 0 as an answer. Now if I provide an expression saying that v1 is less than or equal to v2, it returns me with an integer 1, saying that 10 is less than or equal to 20. Let us now discuss the fourth operator, and that is our logical operator. Now this logical operator, it combines two expressions which contains, and these two expression contains a relational operator. Now when we talked about relational operator, we got to know that the return type of these operator are always in terms of zeros and 1. So we can say that the return type of logical operator is also in terms of zeros and ones. Having said that, let us now look at logical operator in a program. Let us now look at a very simple program that shows the working of our logical operator. As we have already discussed that logical operator works on two expression that contains our relational operator. Now whenever an expression contains a relational operator, we can say that the return type will either be a false or true. Now if we analyze this particular expression, which says that v1 is greater than 1, and that is actually true since 10 is greater than 1. And then if you look at the second expression, it says that v2 is less than 20 or 20, since v2 holds the value 20 is less than 20, and this actually returns us with false since 20 is not less than 20. Now since we are making use of AND operator, it ANDs these two results, that is it ANDs 1 and 0. Now if you look at the truth table of AND, you can see that if the first result is true and the second result is false, then the final result will be false. And this is also what we get in our output. We get 0 indicating it's false. Now instead of AND, if we apply an OR operator, then if we go ahead and look at the truth table for OR, we see that if the first input is 1 and the second input is 0, the output is 1, and this is what we get in our output as well. Let us now look at the working of the NOT operator. Unlike AND and OR operator, the NOT operator is applied only to a single expression. Now if you look closely at this expression, the first expression v1 greater than 1 evaluated to true, and that's why it returned 1, and the second expression v2 is less than 20 evaluated to false, and that's why it returned us with 0. Now since AND operator is being applied, so the result of 1 and 0 results into a 0. Now if you want to make the result of this particular expression as 1 and not 0, what we can do is that we can make use of this NOT operator over here. After applying this NOT operator, you can see that the output written by this expression, which was previously 0, has been negated to 1, and because of which 1 is AND with another 1, and hence it gives us a result of 1, saying it's true. Now that we know what a logical operator is, let us now discuss about increment and decrement operator. The increment and decrement operator are also known as unary operator, and the reason why they are called as a unary operator is because it can work with only one operand, unlike the other operators which needed at least two operands to work with. Even the size of operator is a unary operator, which we're gonna see later in this video. Having said that, let us now look at the increment and decrement operator in working. This is a very simple program which shows the working of our increment and decrement operator. Now as we have already discussed that increment and decrement operator are known as unary operator, and the reason to that is because it works on only one operand, just like over here. The plus plus operator is known as the increment operator, and the minus minus operator is known as the decrement operator. Now if you look at the code within the main function, you can see that In the first line, we have declared a variable v1 which is of data type int, and we have initialized it with the value of 10. And then we make use of a printf function. But the catch is that here we are making use of our increment operator, and this particular form is known as the post increment operator. And the reason as to why we are referring to this as a post increment operator is because we are applying the increment operator only after the operand, which in this case is v1, and that's the reason why this particular expression is known as the post increment. Now what happened in this post increment operation is that the value of v1 gets incremented only after the execution of this particular statement. And that's the reason why if you look at the output, you'll see that in the first printf statement the value of v1 is still 10, and it is only in the second printf statement that the value gets incremented by 1 and it becomes 11. Having said this, let us now look at the pre-increment operation. The pre-increment operation is also similar to the post-increment operation. It's just that the operator, the increment operator, gets before the operand. And if you observe the output, you'll see that the value of v1 got changed in the first printf statement itself, unlike the post increment where the value of v1 got changed only after the execution of this particular statement. Now that we know how pre-increment and post-increment actually works, in the same way the pre-decrement and the post-decrement also works. Now that we know what increment and decrement operator actually are, let us discuss the last operator of this video tutorial, and that is the size of operator. Though there is one more operator known as the ternary operator, but its working is related to the if-else control structure. So once we cover up the if-else control structure, we will then cover this ternary operator. Having said that, let us now discuss about the size of operator. This operator is used to determine the size of any data type, and it gives the result in the number of bytes which is required to represent the particular data type. Let us now see the size of operator in action. Now this is a very simple program that shows the working of our size of operator, and this operator, the size of operator, is used to determine the size of our data types. Having said that, let us now look at the codes. In the code you can see that a variable v1 of integer data type has been declared and it has been assigned with a value of 10. Now when I perform a size of operation for this particular variable v1, which is of integer data type, it returns me with a 4, which means that an integer data type requires 4 bytes of memory. Similarly, when I perform a size of operation for the string community, it returns me with the value 10, saying 10 bytes of memory is needed. But the question that now arises is that the word community is made up of 9 characters. So why is the computer taking up 10 bytes of space? Where is that another 1 byte? And the answer to that is this 1 byte is used to determine the end of this character string. So 9 characters of the community plus the extra 1 byte to determine the end of string causes the computer to show 10 byte of memory. Now if you observe the last printf statement, here in the size of operator I have given a decimal value, and this is the reason why it takes up 8 byte of memory, since this is a float number. That's all for this video, guys. I hope you learned and enjoyed a lot. Thank you.